We're Carbon Squared. We like to think that we give new life to old carbon. Our team consists of our CEO, Dr. Tian, who's at Sapienza, who's a materials physicist with 15 years of experience in cement and mineralization, a former dentist who's now bringing cement to carbon, and Dr. Isabella Romeo, who's a specialty synthetic chemist, industrial and specialty chemistry, and myself. I'm 25 years as an academic, and now it's time to see if we can make some business out of all of this. Got 15 years in disordered materials. We're looking to alleviate pain in magnesite markets. Now, magnesite might not be familiar to you or as exciting as some of the previous conversations, but magnesite is used in a huge amount worldwide in many, many industries. Now, the reserves of magnesite principally reside in Russia and China, but China is dominating the market. Now, where's the pain? The pain is that it's a distant source, prices are unpredictable, and the government has recently stepped in to control 80% of that. Now, 80 times 70, a little more than 56% of all magnesite. Now, magnesite also has another problem, that it comes in different varieties and is often impure and has to be processed, varied processing. Nature also makes carbonates, such as magnesium carbonate or magnesite and we can copy that by taking CO2 that's being captured and magnesium sources. And if you pressure cook it, we can solve the problem of the time that it takes nature to make carbonates. Now, there's solid sources of magnesium around the world, and they come from salt brines and desalination. Now, our technology favors this because magnesium is already in solution. If one can achieve pure magnesite, you get 1,600 a ton. So our solution has been accomplished at room temperature and pressure. This is what we can make. And the other thing is that we can control the properties so that we can service the extensive markets, principally the refractory market, which leads to steel production. It happens as such. We take the CO2 and the brines, we put them into R2D2 or not R2D2, and through a special process, we produce magnesite, again, for these markets. Now, they're more extensive than this, but you get the gist of it, that it's quite varied. Now, how does it work? Well, if we take that said brine that we started with, you add a little bit of secret sauce, and you add the CO2, it's exactly what happens in nature. And it mimics the natural mineralization if you have the secret sauce and the secret process. And what you create is you're creating actually artificial stone, rocks. You're locking in the carbon. This is where most of the carbon is sitting on the planet, 12% of the Earth's crust having to be carbonates. So we took this large scale. This is our CEO's good connection and good friend down in the salt flats in Sicily. We took it large. We went right away to trial this in the real world. And this is what we've produced, our dried synthetic aggregates. This is what they can serve as, sand and rocks. And we've made sure that they're stable for storage in cement plants, and they can be directly used right into the silos and right into the trucks. This truck was actually going out to pour the new runways at Fiumicino, and we're making concrete with it because we didn't believe ourselves. So we took ourselves for a test, and there it is. This has actually landed our CEO a very significant industrial grant, which is in the Clean Energy Transition Partnerships, using the brine to concretely sequester and store carbon. Now, the Carbon Square market targets are not just magnesite, but in fact, CO2 utilization. Now, this market, really nobody knows. It's so new, and CCU, or carbon capture utilization, has no policy as yet. Brine remediation is similar, with desal increasing with the drying world. It can be 10 cents to $1 per liter, but it depends on the brine. But there's definitely a huge market with the 50 billion tons of brine that's out there. So we're looking to get into those markets in terms of satisfying and alleviating brine pain, as well as CO2 pain. So our financial projections that have been done on the back of an envelope or using certain equations like completing the square, they show some good growth. Now, we're going to cut into this profit in terms of scaling up and unknown technologies and going big. We're not always going to have the ability to provide local solutions, so there's going to be transport costs. So this is really an unknown, but we're really thinking that with the growing CO2 problem and desalination growth, that there's going to be a good market for it. And it's really, really novel. So if we look at that, it's reflected in our competition. There's very few that are doing manufactured carbonates, or in this case, magnesite, which we really are specializing in. The other competition is minerals. Mining for these minerals. There's an extensive list of them, and they're not sustainable. Now, there are some that are initiating solar, which is helping take a little bit of the problem of the carbon and the energy sourcing off of the total operation. Our advantages are that we can provide local solutions, room temperature and pressure, so we don't need hazardous conditions, we don't need specialty training or permits, and we can do tailored carbonates or tailored magnesites or tailored solutions specific to the source, brackish water, brines, desal, CO2 neutral. Of course, our golden goal is high-grade magnesite at room temperature. By I think we need 2-3 more years or so, because we've been really having a lot of progress. And with this new industrial grant, I think it'll accelerate things. Business model is circular, truly circular, because we really learned from the last step. And this direct pain relief is a feedstock source, but we can also go out on site and produce blocks at site and leave them there for construction, for seawalls or otherwise. Product development, we do a lot of computational modeling, and distribution and sales might just be direct sales or custom solutions, where some of these concretes or blocks are either fracturing or not. Earthquake resistance, for example, we've been able to resist up the fracture toughness of these systems. Roadmap looks as such quite bumpy, like the stuff that we're making, but I'd like to point out particularly that the flow modeling and the machine learning, this is something that we do, engineering scale flow models, to provide custom products, wide-ranging solutions, and put us on the global market. That's really what we want to be doing. So to wrap it up, ambient manufacture of magnesite and other minerals, because similarly in nature, we see this kind of mineralization process proceeding at room temperature. Nature takes more time, but again, secret sauce or a magic formula can help us get there. Pioneering carbon utilization in water mining. This is a new term. People are now mining sewage. People are mining brackish waters. There are tons of minerals, and it's really a huge opportunity, but it's really at its infancy. And I like to point out that we do nanoscale through bulk approaches with multi-scale modeling, drawing on the expertise of our whole team. So with that, I'd like to thank you for your attention. Obrigado, grazie, and shishnia.